And before the class was even over with, a student walks up and he's like, well, what happens if you do long division? I think we can do long division. I got a good answer when I did long division. So we'll do long division. Just so you can see. Y'all can try use substitution and try to set things up to make this turn into one of those formulas that I gave you for inverse trig, but it's not going to work. You can go through. If anybody looked at this problem on the homework, if you try to make x squared u squared, it won't work. So you have to take a different route. This is the best route to take for that problem on the homework. But if y'all need to see that, you can look at that in just a sec. Let's do some long division real quick. When you divide with long division, you're supposed to have all your terms. So like in Algebra 2, just real quick, in Algebra 2 you learned that if I was doing like 3x squared plus 4, and I divide this by, let's just say x minus 3. What you would do is you would take x minus 3 and you would long division divide this into x squared plus 4. This is not going to work out though. You're supposed to put a placeholder in here. Let me show you why. I need to look at what can I multiply x by that gives me 3x squared. That's 3x. It's the same thing as taking these two things and dividing them. Alright, then you take your answer that you get and you multiply it back to both. 3x times x, 3x squared. 3x times negative 3 is negative 9x. There's a problem right here because we're supposed to subtract, and these are not like terms. So in algebra we said we just put a placeholder of 0 here and then put the plus 4 to the back. So that when you subtract, that it all works itself out. You got to have a placeholder. Same thing happens here. I have something that's squared. Y'all see e to the 2x. So I need a placeholder. 0. E essentially to the x plus 0. I have a place. I have something to the second power. Here's to the first power. Y'all don't actually have to fill it in as nice as me, but you need to know that when y'all do this and you're trying to subtract and it doesn't actually subtract, it's easier to see right over here. It's because basically you just need to put a placeholder of 0 in there. Terms don't match up, you gotta put 0 in. When you do long division, you only look at the first terms. What can you multiply e to the x by? That'll give you e to the 2x. Yeah, for sure. Don't forget that when you're multiplying things with the same base, that you add exponents. So this would be e to the 2x. So what can I multiply e to the x by? That gives me e to the 2x. That would be e to the x. Multiply this back to both. E to the x times e to the x, e to the 2x. E to the x times 3, positive 3 e to the x. And because I put this placeholder here now, it actually sorts itself out. Subtract. This should always cancel at the front. What happens when you do 0 e to the x minus 3 e to the x? Negative 3 e to the x. And when you do long division, after you subtract, you're supposed to bring down the next number. Now I'm looking at the... Yes, what can you multiply e to the x by? That gives you negative 3 e to the x. Negative 3. And then multiply negative 3 back to both here. Negative 3 e to the x. Minus 9. Subtract all this crap. No. Yeah, because you're subtracting a negative, so you get positive 9. Well, you're supposed to bring down the next term. Bring down the next number. There is no next number, so that means that this is your remainder. So we put plus 9 divided by whatever we were dividing by. E to the x plus 3. Y'all know in middle school when you put like r for remainder?
Yeah,
Remember that? No such thing as r.
There's no such thing.
No, r. This is r9. I mean, this is r9. This is remainder 9. But you all were never actually shown the math behind that until pre-calculus or algebra 2. Okay, so that means that this is this. E to the x minus 3 plus 9 over e to the x plus 3. Dang, Mr. Slazak, did this problem, did we even make that? Did we make that easier? It's close. We're almost there. Watch. I need another piece of paper. We don't like that denominator. So if y'all have a whole bunch of pieces strung out and you don't like that denominator, you should multiply all of them by whatever the denominator is. Y'all remember that? Wait, am I allowed to do that? Miss Sprouse?
What?
I can't multiply all these. 10, that's what we did the other day, but
Just separate it.
yeah, I actually can't multiply all these by the denominator, y'all. That only works when it's a problem like this, like minus 4 over x equals like 3 plus x over. If you don't like all these denominators, then you could multiply by like a common denominator all the way across, but that does not work right here, because there's not an equal sign. Sorry, 10. I told you, wrong math. We just gotta take the antiderivative. Antiderivative of e to the x is e to the x. Antiderivative of negative 3, negative 3x. No idea what the antiderivative of this is.
Oh, just really think.
Plus, I don't know. What do we do with this? We need to make,
Add one.
add 1.
No. You gotta add X, right? You gotta add X.
No, that's not gonna work.
Wait, hold on. Look.
I don't have it so y'all can see it. There you go.
So if there's an e to the x in there, you're not saying the same, right? That's what you're saying. You said you read it. So it's e to the x. So with that same thing. And then you have here, then it's not. One over one on the outside. What?
So you do it this way.
No, because it's plus. What move needs to be made right here to take the antiderivative of this?
Use substitution.
You change it.
Okay, good.
Wait, no.
Oh, wait a minute.
She said it's right. Yeah, she do it.
No. 10, did you take
Yeah.
that? Did you do this?
And then it's 1 over e to the x plus 3. And then you can just do the natural
Natural log.
log.
Plus 9, 1 over e to the x plus 3.
Yeah.
This is natural log.
Yeah.
Brandon, I don't recommend this. But it seems like, because this is what some people ended up doing on their test, and it didn't work out very well for them.
Call me.
But if you take the derivative of this, it's going to end up spitting out the derivative of the inside. So if I take the derivative of this, eventually I'd have to multiply by e to the x. But I want that gone. So I'd have to divide by e to the x.
Yeah. I think that's why I did use substitution from the beginning.
Or if you use substitution, then it kind of
Then
works
did-
out where you
and
have
then
to.
did long division with the use substitution.
Whoa. Makes me feel happier that I was looking at it for a long time, because it is a crazy problem. All right. Hey, at least you got some long division. Review. That was good. Some placeholders. Let's do it.
Definitely, this is easier. Because this one, like I said, if you,
Everybody got the notes?
this would have been 9, but you have to be over e to the x, so, because if you go backwards, it has to take the derivative and come back to that again. So you put in the x. would have
Hopefully we'll be able to
cancel out.
finish. I can't spend too long talking about the proofs. We just gotta do it.
Yeah, I think it's quite that difficult though. Thank goodness not.
Sweet. Okay. You're nice and rested now.
It's gonna be rough.
All right, y'all. Notes.
It's been a rough day. We want you to feel that way.
Congrats. This shows up a lot if you keep on going through, like getting an engineering or a math degree.
Yeah, these are
I almost got
different,
this tattooed on my body,
which is the beginning of
no
the
joke.
attitude.
but I have an addictive personality, so no tattoos for Mr. Slazak. I might not be able to stop.
Did you actually do that?
Because you missed the first part. If you get a degree in math or like engineering, then it'll just so many things that you do in your time at university. You'll see this. And y'all have already been doing this. Y'all already, if I gave you a definite integral like this, you would find the antiderivative, which we just call capital F. Okay? And then you plug in the upper bound first, and you subtract off the lower bound. It's called the fundamental theorem of calculus.
Part one.
Part one. There's some parts to it all. If y'all want to read through this proof, great. Let me tell you what it says. It tells you that you are taking y values and multiplying it to the width, delta x, so a change in x. You're taking tiny, tiny little rectangles, infinitesimally small, so like almost infinitely small rectangles, and you're adding them all up to get the area. That's what that says, and that's what all this proof is saying right here. It connects back to that whole Riemann sum stuff. Okay, cool. We don't need that right now. We gotta know how to do the problems. That's what Russell's waiting for. Once we get to the problem, Russell, we'll definitely make sure that you're ready to go. Okay. What I told y'all about taking the integral, you get capital F. This is important down here too. It kind of like just sums up what we just said. Take the definite integral, find the antiderivative, and then subtract the value of, where's the, oh yeah, the lower limit from the value of the upper limit. Great, that's what we said. Let's do a problem. Good, Russell, perfect. This is what you like, Lita. This is the easier stuff. Alright, so for this one, you're gonna have to do U substitution. Just kidding. Just add 1 to the exponent and then divide.
Hello, anybody awake?
They're kind of awake back there. Let's try to connect some things here. So if you're looking through your notes and you see capital F, that means antiderivative, and capital F for our problem is x squared over 2. Okay, capital F is used a lot of times to say antiderivative. We need to evaluate from 2 and subtract off the lower limit 1. This is the area under the curve when you're looking just from 2. function looks, I don't know, I just, quick little graph, function looks something like this. This right here is telling us the area all the way across. That's what this is doing right here. But then we need to subtract off and take all that crap off right there. So we just have this area from 1 to 2. So this would be what? 4 over 2 minus 1 over 2? Which is 3 over 2. 3 over 2. Number 2, find the area under the curve. Do it. There we go. Find the area under the curve. Y equals cosine x. It's telling us to take the antiderivative from 0, pi over 2 of cosine x dx. We saw this simple years ago and we thought it would be something way crazier, didn't we? Come to find out the math is still really hard. Wish Will was here. I'd ask Will what the antiderivative of cosine is. Muhammad. Russell. I know y'all like the trig functions.
No, I don't.
Negative sign? Is it negative sign, y'all? So if I have negative sign right here, I can check my answer by saying, what's the derivative of negative sign? And it should get me back to there. So it's just sine, yes. I have a whole degree in mathematics and I still do what I just asked y'all to do. To this day. Because it's kind of hard. And I'm looking from pi over 2 to 0. Y'all do that real quick because I forgot I needed to tell Savannah about her homework. Probably I didn't read the explanation why this one right here. I'm looking at sine pi over 2, which is 90 degrees, minus sine of 0, 0 radians, 0 degrees, which is 1 minus 0, 1. Next. I don't see the reason really to do number 3 right now. Anybody solve number 3 already? We need to save our time, y'all. We gotta go to the harder ones. Y'all should know how to do number 3. Let's skip that, go to 4. I don't have to worry about the 5, just throw that to the front. The antiderivative of e to the x is e to the x. Can I use symbols like this, or do I need to use a straight line?
Most of the time, just use a straight line.
Guess I'll go like this then and try to make the symbols look right. I don't know if that parentheses was even necessary. It's not necessary. Natural log 3, 0. Which gives me 5 times e natural log 3 minus e 0. Problem looks so familiar. I feel like we did this one last class. We did this exact one.
As an indefinite interval?
No, that's a. Maybe it was indefinite. Yeah, it might have been indefinite. We did a long talk last class about this though. E and natural log. Logan, you missed this. E and natural log.
Yes.
They cancel each other out. You'll hear that a lot. And it's just 3. So this is 5 times 3 minus 1, which is 10. There was a problem. one of the problems on the homework that was due today that Christian was asking about. Logan, you especially might want to take a sec to look at this. The e and the natural log cancel, but what's up with that 2 right there? So we talked about some other rules where we said the 2 becomes the exponent. So it's actually e natural log x squared. E and natural log cancel out, and then it makes the problem so easy. Anything that's an exponent can always be brought down in front of a log, or vice versa. What's wrong with you? I almost said number 5 is too easy, but I'm seeing that number 5 might not be too easy for some people. Number 5, this is e to the negative 1. So if you tried to add 1 to the exponent, you'll get e to the 0. Don't be trying to smack God in the face, because you'd have to divide by 0, and you're not allowed to. I can't take 5 iPhones and divide them amongst 0 people. So this is natural log x, 2 to 1. Where we get natural log 2 minus natural log 1. So many rules with the natural log.
Natural
So
log.
many.
That's how you
Yeah, but I don't think I have any questions.
Y'all know what natural log of 1 is?
Maybe it's
When x is 1,
depends, like, when the words are different, like, if they talk about just the octanile function.
I could show you the graph real quick, and I can show you what it's going to be on the graph, but then you could do it in another way. Here's where natural log equals 1. Y value 0. Another way of looking at this is natural log of 1 is log base e of 1. What does this equal? Well, I don't know what it equals. I'll just call it x. E raised to the x equals 1. Logan, we talked about this full circle also last class. You remember the full circle? They're the same. They're equivalent expressions. And the only thing that makes this work would be e to the 0. So natural log of 1 is 0. Oh yeah, there's another rule. It's gonna take us to the same crap, y'all, but you gotta see this. You gotta see it! For natural log, if you have 2 things that are subtracted, then you can go that this is natural log of 2 divided by 1, which is just 2. Natural log 2. Which is the same thing as just saying, hey, this is 0. I forgot something. Very, very slight. Right here, maybe I'm wrong about definite integrals. Maybe Ms. Sprouse will have to step in. But I was told that I'm supposed to use absolute value.
I think the actual formula is for the indefinite interval.
So
But
you
if it's
only
a
use-
definite, yeah, if it's definite, you don't need it, because you're on a certain.
Oh yeah, you're plugging these numbers in anyways. But if
Yes.
you don't have numbers to plug in, then we use this. Like if we didn't have any numbers, we would say absolute value, which would just be saying that the function only exists over here, where the x's are positive. That's some good crap. So we don't need the absolute value. They get tired out there on last period of the day. This is a dangerous period for calc.
We had a sex period, didn't
That was like,
Try number 6. Use your brain. Try it. I can only really afford you like 2 minutes or however long it takes me to go over here. Alright, so we should have natural log x.
Yeah, but like.
From -1 to -2. Whoa. Which is natural log -1.
Yeah, it's like almost like we have like so many and maybe it was
Ms. Sprouse, I have a question about this real quick. Sorry for interrupting.
I'm sorry.
No, it's
We're talking
okay.
about mu alpha theta.
It's all good. Because both of these do not exist, are we allowed to divide these?
It's not divided, the negatives cancel, most of them have.
Yeah, the negatives cancel if you divide it, but right now these do not exist
Yeah,
because
see,
natural.
I put it in absolute value.
Oh, you did put it in absolute value.
Because of the negative.
Right. For that, because it has negative limits. If you already have
Okay.
positive limits, you don't need it. But if you have negative limits, then you have to use your absolute value in order to find the area.
We have determined the rule here that we are using natural log of absolute value x. We used it right here. Y'all might want to go up and just change these on your paper to absolute values on the previous problem. All of these are absolute values. Absolute value, absolute value.
Yeah, he doesn't like stats.
We were talking about it should have been absolute value up here, Christian.
Yeah, I
but-
heard us talking about it, but I'm like, so big adjustment.
Yeah, so now it makes this possible because if not, the natural log of -1 does not exist. That's not a thing because over here at -1, the graph's not even there.
I'll never understand
Natural log of 1 minus natural log of 2. I don't even think we've already done the absolute value, so pretty sure we do not need the absolute value right there.
Do it as 0 minus natural log of 2.
0 minus natural log of 2. You could make this 0.
Would you get different answers?
No. Because if you leave it as 1/2, this is the same thing as natural log of 2. I don't think I need these absolute values anymore. After I did the absolute value once. I highly doubt that you would have a multiple choice answer where they have absolute value and then they have the same answer without absolute value. That would be very messed up, but
That'd be like an AP style question.
right, that would be
That would be the style question. It's the-
Like you showed me how this was like 2 0.
which is the same thing as negative natural log 2. Like I told y'all earlier, you can bring the exponent down. So if you make this 0 right off the start, it would be a way smarter way of doing it. These last couple of days I've just been non-stop teaching about natural logs. Sweet. Alright, y'all ready? Any questions on that at all? Any serious misconceptions? I'm 99% sure you don't use any more absolute values because like in algebra, when you take the absolute value of something, you don't keep the absolute value there afterwards. You've done it, so you take it away. 99%. 99.9. Alright, number 7. Being able to take the antiderivative of this is going to involve y'all understanding that If I take the derivative of something, then I'll get this. If you take the derivative of something, you'll get this. It is secant. Good job. The derivative of secant. Hold up. The derivative of secant x is not something that y'all might know how to do right now. You would have to make this 1 over cosine x, and you'd have to do the quotient rule, which you would do the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. This is just 0. So I'll have sine x over cosine squared x. And I need to split one of the cosines up and leave a cosine here and then put a cosine at the end. And I will find that this is tangent times secant. Which means the antiderivative of this is what we started with. Secant. Alright, cool. I'm zoomed in like crazy though. So this is secant x from pi over 4 to negative pi over 4.
Yeah, the tangent's the same.
And I have to go to the back for this. Secant x pi over 4 to negative pi over 4. Oops. Secant pi over 4 minus what's secant pi over 4?
No, not in the area, not in the area. You know what area I'm talking about, right?
Oh yeah, that's for inverse. You don't gotta do that for this.
So it can be anywhere.
It could be anywhere.
You should be thinking cosine and flip it.
Yeah. The cosine is
1, 2, 3, remember?
sine,
What would be right in the middle of your 1, 2, 3 chart? What are those numbers?
2.
Yeah, it's just square root of 2 over 2.
Exactly.
Yes, cosine would be square root 2 over 2. We need to flip it right here.
So 2
Square root of 2.
You could get rid of the radical on the bottom, but I mean, you gotta at least be right here off the start. This is the same thing as with rationalizing or not. Minus
And negative the same thing.
secant negative pi over 4. We need to know that if we go down here, negative pi over 4,
It's not gonna
you're gonna get the same exact answer here as if you go up.
Yeah.
Because we're talking about x values. X is the same here or here. You go to the right the same distance. So it's the same. Minus 2 over square root of 2, which is 0. That's type stuff. No bojangling. Christian Uber. On back. This is for Will. He can thank me later. It's on the back. On the back.
Yeah.
Number 8. Absolute value x. Uh-oh. Absolute value x from 2 to negative 1. It's been a while since we looked at absolute value x. Y'all know absolute values have a positive sign and a negative sign? Y'all remember that? So this right here is the same exact thing as saying y equals x, as long as you're over here greater than 0. If x is greater than 0. And then y equals negative x if x is less than 0. The graph looks like this. This is negative x. This is positive x. This is how absolute value works every time. You can always take one, take this and put a positive on it, and then take one and put a negative on it. And it splits up into two integrals. Alright, so let's look at this side. What numbers should we use? If we're looking at negative 2 to 1, and I just want to use this side of the graph, negative x, what numbers should I be looking at on this interval? We would be right here, negative 1, all the way until 0, right there. So from negative 1 to 0, I'm going to be looking at negative x. We're just talking about area under the curve, y'all. So I'm going to add on to this the other part of the area under the curve, which is from 0 to 2. But from 0 to 2, I'm going to be using the positive side of this function, positive x. This is how this will work, even if it becomes more complicated. If it was like absolute value, x plus 4, what have you, there would be one side where you have negative x minus 4, and then positive x plus 4. Every time. Pretty nice. So I have what? Negative x squared over 2 from 0 to 1, and x squared over 2. I forgot to put the upper limit in there, from 0 to 2. And math's nothing again. It's taking concepts y'all learned in Algebra 2 and they really is extending it out. Y'all should have learned that. I should have put the should in there. Negative 0 squared over 2 minus negative 1 squared over 2 plus 2 squared over 2 minus 0 squared over 2. We like 0 in math, y'all. A lot of times 0 makes everything so easy. 2 of the pieces just go to 0. Bring down this negative. I have to do 1 squared first.
This one is negative.
Which is just 1, but don't forget that negative still in the front. So this is negative 1/2. Ends up being positive 1/2. So it's negative negative. Y'all seen that? Plus 4 over 2 plus 4 over 2. 5 over 2. Alright, cool. Anybody still copying that? Number 9 is about the same, y'all, except for it's kind of long, and I need to get y'all through the notes, so I'm only gonna like kind of set it up. We're not solving all of number 9. Number 9 will turn into similar crap. We will have the integral. I'm looking from 0 to 6, but they told me that the function equals x squared when x is less than 2. Wait, when the function is less than 2,
So from
not
zero.
equal to. So from 0, we're doing x squared right here. Am I allowed to put 2?
Yeah.
But you're not equal to 2.
But it will be on the other side, so it'll connect. When you do the graph, it's like the closed circle, the open circle will
Opens.
become closed when you graph.
Oh, yes. Okay, I'll try to show you a quick little graph.
Yeah,
just so you
I
can
always
see.
did the sketch.
So what would happen is you'd have x squared until you get right here, and it would be an open circle. But then this function will end up picking up right at x equals 2, because when x equals 2,
You get 4.
yeah, get the same thing that I got right here. 2 squared is 4, and right here this will be 6 minus 2, which is also 4. So you end up filling this in and going off as a line. Oh, so we are allowed to use 2. I was concerned about that. You know, it doesn't say equal to, but we're straight. That will probably happen most of the time, I'm sure. Because I don't see how you would do it if it doesn't work. So, and then from 2 all the way to 6, you'll be looking at 3x minus 2. I'm supposed to have little dx's in here, y'all. dx, dx. Cool. What's the answer at number 10? We should know number 10's the answer. You also copying?
We'll flip it over and write on the back. There's also paper over there by you. There's paper over there you could write on.
I like to think about this graphically, and I can see graphically that it
Okay.
is 0. But y'all can think about this in a non-graphical sense. Whatever you get, y'all, when you plug 1 in, you're gonna get some number. You're gonna have to subtract off
It's the same
the
number.
same thing with a
It's
1.
only 0.
So it will be 0.
There is no distance between 1 and
Yeah.
1. So
Yeah.
therefore no area.
There's no shape. It's literally just a line that would be going straight down at 1. So there's no area inside of a line. It would have to be a shape of some sort. Sorry? Yes. Okay. Number 11. I don't see anything that makes that problem hard. So let's skip through that. All right. No, Mohammed, we never did number 9. I just kind of set it up for y'all because I told y'all it was just like the other type of problem, but I at least wanted y'all to see how you'd set it up. Y'all should know how to finish that up. I'm not doing that. Y'all, are y'all scared about this 3x minus 2? Anybody scared of taking the integral of that? It would just be 3x squared over 2 minus 2x. Yeah. Remind yourself the names of these real quick. When you're looking at actual values, this is called definite integral. And if you're not looking at actual values, this is indefinite. I will definitely know the area. I can definitely plug in the numbers and definitely get the answer. But this one's not definite. It's going to be some capital Fx plus C. Indefinite. All right. All right. Next page. where are we at? Okay, cool. I can really overcomplicate this in my brain. I don't wanna, like, my brain can go off in the left field, so I don't wanna speak too much about this. This is the mean value theorem for integrals. You do not have to know this actual definition right here. I don't wanna say too many words. Ms. Sprouse, I need help. I mean, it does connect over here to this
Did
average.
you all watch the video that was in Canvas? He needs to be slapped. Because the video has this exact graph and shows you how when you do the area under that curve, that you have to form a rectangle that will capture most of the area. But if you went all the way to the top, then you would be overestimating. If you went to the bottom of the curve, then you would be underestimating. So if you go midway, you see symmetrically, you have the same amount on the left as you do on the right. So that's what it's saying as far as the average. You're looking for that area that would capture it under the curve, but you want to find out what is that X star, which we call C. It's the X value, such that that point would be on that curve. And what you're going to come up with is that C. But the average value that you come up with is going to actually give you the Y value for that point. So you're going to use the average value to find the X value. Does that make sense? Take your time when you think about it. You're looking for C, that's your goal. You're going to use what's called the average value function, which is related to the mean value theorem for integrals, to find the Y value at that point on the curve. Well, if you set your function equal to that Y value, it is going to give you your X value. And in this case, my X value is the C that I'm looking for, that's going to guarantee that that point is on that curve. So the first thing you really want to look at is, how can I find an average value? How can I find the Y value associated with that point?
How can we find this right here? Which is, for us, is F of C. And this is called the average value. So if you do this, the average value would be, you have to divide B, this is the formula that y'all need, okay?
Yes.
So what I'm about to show y'all, you divide B minus A on both sides. So you would get 1 over B minus A. Y'all need to label this as average value of F. Sometimes called F, like AVG,
Yeah.
like this. Average value of F. Oh, eraser. I divide B minus A on both sides, and I'll end up with this right here. My fault, there we go. F of X, dx.
A to B. And your integral. The integral sign, A to B.
Oh yeah, this is definite integrals. We're looking from A to B. Make sure you put the lower and upper limit.
And that will be for the average value.
If you do this, it'll give you that F of C. Oh, hold up, there we go. I need to zoom out a little bit, I can't do this. Can't keep on sliding like that.
There you go.
Nice. Average value of F, 1 divided by B minus A, times the integral from A to B of f of x. If you do this for a certain function, then what it will do is it'll find this y value, which if you made a rectangle with that y value right there, y'all see how the rectangle's made? It ends up being exactly the area under the curve. That's kind of nuts. It's hard. I can't even like completely see that. But that is the average height of whatever function you're looking at. If you draw a rectangle, it'd be the area under the whole curve. Wild. All right, we said a lot of words. Most people might not have like taken all that in. Let's do a problem. F of x equals x squared from 1 to 4. Should I draw a picture now or afterwards? After? After. All right, let's find the value of, this is C essentially. Find the value of C guaranteed by the mean value theorem for integrals. There's basically gonna have to be two parts to this in a sense. Like I'll label it like 1 and 2.
Y'all pay attention, it's on the test, it's on the quiz, it's on the AP exam, you're gonna see it.
First we gotta do this. 1 over b minus a, and then the integral of the function. So we have 1 over b is 4, a is 1. Multiplied to the integral of f of x, which is x squared for us, dx.
Put your limits.
We did it again last time. We did it just like last time.
You're consistent.
And we are going to be evaluating this from 1 to 4. Come on, Slazak. This is equal to 1 over 3 times x cubed over 3 from 4 to 1. Or from 1 to 4, I should say. We don't say from the top. We say from the bottom. 1 to 4. Remember, this is going to be the y value. This is not c that we're finding. We are finding f of c. So this is 1/3 times 4 to the 3rd over 3 minus 1 to the 3rd. So I get 1/3. 4 times 4 is 16. 16 times 4 is 16 times 2, which is 32, and then just another one, 64. 64 over 3 minus 1 over 3. Which is 1/3 times 63 over 3. Oh, not enough? I mean, not as too much? So this is 21. We don't need to keep on writing.
We gotta get them to speed up a little.
21 divided by 3. There's no such thing as dividing, by the way. Division's not even an operation in math.
1/3 of 21.
1/3 of 21 is 7. So we have figured out that f of c equals 7. Straight? Which is from up here, right? This was f of c. We solved it, it's f of c. How do we figure out c? What's the x value? How do we do that?
Take something, plug it back in. Yes.
Kind of.
7.
Oh, I don't even have it so y'all can see. What's f of x?
C.
F of x is y. What's
But
f
what
of x
is
for our
f of x for
problem?
this problem?
No,
So we're trying to figure out where's x squared equals 7.
That's right.
That's what it's asking. F of x, which is x squared, or we could call, y'all remember when we did mean value theorem, we put a c in? So we said instead of x squared, we call it c squared. You could put x squared right here, you just at the end, most of the time we would say c equals. So c equals plus or minus the square root of 7. But we're not going to keep the minus. Why don't we keep the minus?
Because you're messing with integral. It can only be positive.
No, it has to do with the interval.
Yeah.
Oh, you knew back there? You might have waited for us to say the answer. We're only looking for x values. We're trying to find an x value right now from 1 to 4. So you can't use negative square root 7 because that's not in the interval 1 to 4. But square root 7 positive is. So we just keep it positive.
Yeah, you might want to show the graph.
Which means at square root 7, if I draw a line up to the graph like this and make a rectangle, that rectangle will be the same thing as the area under the curve from 1 to 4. Draw a quick little graph. 1, 2, 3, 4. When x is 1, y is 1. When x is 2, y is 4. When x is 3, 4, 5, 6, 7, 8, 9. When x is 3, y is 9. 10, 11, 12, 13, 14, 15, 16. My fault, y'all. I had to zoom back in. There, no, you probably won't have time. Unless you can draw really fast. I'm looking for the area underneath this entire curve. Square root 7 is like,
2.6.
let's see, square root of 9 is 3. So it's gonna be a little bit less than that. 2 point something.
2.6.
It's 2.6? How do you know that?
Good.
He's good. I might be that good one day.
And did you forget who you're talking to?
Shut up, Russell.
And it visually kind of makes sense because this extra area right there that's outside of the curve it looks like about the same exact area as that.
Very symmetrical.
Right, so you can like visually see right now that the area inside the rectangle is the same as the area under the curve. And that's what the mean value theorem helps us find out. It helps us find that average value where you make a rectangle and find the area. Whoa! I didn't know how this words were gonna come out of my mouth, y'all. I thought it was gonna be really, really bad. It actually kind of made some sense. To me, I hope it made sense to some others. So Randy's like, I don't know. All right, next. Fundamental theorem of calculus, part 2. What do I need to not say to you guys? Boom, boom, boom. Okay, here's the main thing. Y'all gotta look at this right here. Y'all know that this is the second part of the fundamental theorem. You know that derivative and integral are just like reversing each other, right? They're kind of like square root and squared. Like square root and squared. What happens if you square root something that's squared? Goes away. Cancels out. So this is what happens right here. That's as long as these are not like actual functions. Okay, so if there's actual like functions there, then it's not going to be as simple as that. So let's look at this next one. Dang, Brandon, you're already gone? Okay, derivative and the integral cancel out. Do I do any adding of an exponent? Do you get t to the 4th over 4 for this?
Well, if the upper limit is the function, then you just evaluate the antiderivative at that function. So the derivative and the integral will cancel out, but the result will be the function evaluated at the upper limit. Did I say that right?
The answer is going to be x to the 3rd.
Yep.
Alright, let's read this. Let's read this rule.
Yeah, we're trying to.
I mean, you can prove it, you can show it, which I did, but for the sake of right now, that's the most important thing that they understand.
Alright, if a definite integral has a variable upper limit of integration and a continuous integrand, the integrand's just the inside function right here, it's gotta be continuous. Then the derivative of the integral with respect to its upper limit, with respect to x, is equal to the integral evaluated at the upper limit. So you do take the integral. You get t to the 4th over 4?
You can show it all out, and what's gonna happen in the end is exactly what I said. It's gonna wind up where the derivative cancels out the integral, and then the function becomes a value of x, which is the upper limit. But
Okay.
you can do it, I mean,
These cancel each other out, and we have to take the upper limit x and plug it in. The answer is x to the 3rd.
yep,
If, this is the proof right here, because I can't do it without like showing it to myself.
yeah, if you look right above where you're writing, see that definition? Where it says ddx in the brackets equals f of x.
Oh yeah, you just end up getting the function with x plugged in.
There you go. I mean, you can do all this out and you'll come out with the same thing.
This will give me the same thing. Wow, I'm so confused by this. X to the 4th over 4
Let's leave that.
minus 1/4?
Just like that.
That's crazy. No, I haven't been able to do anything for Pascal. I'll look at it though. He doesn't know problems that exist out here.
So what you have now is f of capital F of x. Now take the derivative of that.
Oh. We work from the inside out, just like so much in math. We did this inside stuff. I did the integral, I got this. I haven't done the derivative yet, okay? Mr. Slazak, I'm on board, I'm straight. I did the integral, boom. And this is the integral right here. But I haven't taken the derivative yet. I haven't done that outside piece. So f, capital F prime, which would be doing that outside derivative, would be equal to, bring down the exponent, so it would be 4x to the 3rd over 4 minus 0. Whoa! Okay. Y'all can tell Mr. Slazak was really prepared for today, weren't you? Had lots and lots of hiccups and could not do what I needed to do in my planning period. You just get x to the 3rd. That's crazy.
So guess what the next answer would be?
So that's what this is saying up here. If you're going from, doesn't matter what number this is. It could be any number.
Any constant
If A is any point in I,
in the interval.
that's crazy. All right, then you just end up getting that right there. So it's the same thing as just saying these two things cancel, and you just plug x into the function. You just get x to the 3rd.
Yep.
All right, let's do that for the next one because we don't want to keep on doing all that. The derivative and the integral cancel out, and you just have to take that x and plug it in. I'll get sine x.
Yep, and it works.
That's crazy. All right.
I'm
This
just-
is why Miss Sprouse a second ago, I was like, I don't think, I looked at her like, we're not gonna make it through the notes. She said, we're good. That's why. I think we might have to take off some of the homework though. I don't know if they'll be able to do all the
The only
homework.
part they might not get to is when it's an upper and lower function.
Oh, okay, alright. Hey, the announcements might start anytime now, y'all, so just take a sec, look up here. I know I've been asking for your attention for like an hour and a half, but I really
Hour
need
and
your
5
attention now.
minutes.
Yeah, but this stuff is so cool, you gotta love it, right?
I just totally fell in love.
Same.
Right off my feet.
On the homework, if y'all have functions like this where it's not X on the top, there's like a whole new set of rules for that. It gets a little bit harder. You're not gonna be able to do those problems. I guess I'll start the next class off by showing you one, let you practice one.
But it's cool, cause that's just like the chain rule, so,
I know,
I mean.
we like that one. I was ready to show y'all that one. Alright. Let's find f of 1. Given capital F of x equals this, find f of 1. So when x equals 1,
Hello.
f, capital F of 1 equals. Is that right?
Oh, wait.
They tell us that
Say
x is
0.
1 because it's capital F of 1. So my upper limit, which used to say x, is now 1. T to the
Yeah,
third.
there you go. And we already know when the limits are the same, what's the area? 0. See?
So we are looking for the area between two numbers, but the number is the same. So there's no area
0.
in between there. This is 0.
Now you need to find the derivative.
Now you gotta find
So
it.
you're doing just what we did before, d dx of an integral.
We'll write it out nice.
Yeah, write it out like we saw before.
Capital F prime of x is take the derivative of this integral
From 1 to x.
of t to the third plus 1 dt.
And you should know that answer right away without any work.
Or we could go through and we could do the integral on all of this, and then we could take the derivative of that stuff. We could do that. We learned that that sucked. Mr. Slazak likes this in math, though. I do it the hard way first so that this will really stick in my head. All I have to do is take x and plug it in right there.
That's it.
It's x to the third plus 1.
What is this called?
You saw that, Savannah?
This is the derivative.
Good job.
It's actually from
I saw it
here.
too, just a couple minutes ago. Sorry for that, y'all. Y'all can probably tell when class started I was flustered. There's things happening outside of school.
Is that it?
It's not that big of a deal, honestly. It's just really backed me up. Alright. It's the same.
So f of 3, we should be able to answer right away.
F of 3 should be really simple for this one because the lower limit is 3. So when you're looking from 3 to 3, it's going to be 0. Let's just try to get down with the notes. Capital F prime.
Yeah, it's funny because
Of
these are
3?
the kind of questions that you wouldn't see in multiple choice.
I'm
And
taking the
answer's so easy.
derivative.
We do all this one. You know, limits are the same, there's no area.
Ms. Sprouts, was I right up here when I put derivative with respect to x? Because we were doing it.
It should have been T,
This should have been t.
but.
Yeah, so like right here, this should be
DT.
d
Good afternoon, Patriots. We are glad you were present today, hoping that you were punctual and plan to be tomorrow, kept a positive attitude, and had a productive day. Due to safety concerns, students are not to have both earbuds and nor headphones covering both ears at any
God
point
damn,
while
why
in
is
the
it so
facility.
loud
Students need to be
today?
able to hear
Because
any
the
directions
function is
given in
X.
the event of an
The
emergency
upper limit is
situation.
X.
Snack sales for students will not be done during instructional time. If you
What,
would like
this
to
one right
purchase
here?
snacks during transition, you do so with
Well,
the risk of being
the
tardy,
reason why they had
detention,
DD
or concerns. Tickets are $30 a person. Attention juniors and seniors. Debbie High School will have its third and final ASVAB test Thursday, April 11th at 7:30 a.m. in the senior cafeteria. To sign up, simply click the link or scan the QR code that was sent to your emails and you can also sign up by logging into Naviance, locate the What's New tab, and find the ASVAB event and click the green box to register.
Derivative, but I was thinking that this was about to be
Prom
zero,
will
but
be
if you
held
look
May
at it
3rd
like this,
the Holiday Inn. After prom will be at the community center. Your prom
It'll
ticket
be a
is
lot
after prom
easier
as
to
well.
see.
The cost is $80. Guest tickets are also $80. If you have any questions, please see Miss Tally or Miss Coates.
So the X
Football
squared plus
conditioning will
one.
take place
There
today.
you go. Now,
Athletes are told to report to the cafeteria for starting ball.
That makes more sense.
Weightlifting and workouts will follow. Permission forms for the Wheelie field trip for Saturday are due to Miss Baker in room 238 tomorrow. Please hold
nice,
for discussion.
okay.
and then they have double prime, you'd have to take the second derivative using the first derivative, of course. Which they should be able to do that rather quickly.
I know, you get 1/2 square root x squared plus 1, and then the derivative of x squared is
2x. right?
2x.
And then the twos will cancel.
Oh yeah, boom, boom.
There you go. So f double prime at 3, you just plug in. There you go. And you can leave the radical on the bottom.
Yeah, we don't care about radicals on the bottom. Calculators
These are really typical type of problems that they have on there too.
on the exam. Something that could be made really hard unless you just
You
understand.
don't see it, yeah.